thank all of you for coming here today. And as faculty do, I'm going to take the liberty to, before I actually get on with my job, to actually congratulate all of the undergraduate researchers who are showing off their work today. Your lives have now been changed in the fact that you've embodied a question yourself. You've gone through the process of research, and now you're delivering science in a form, or art in a form such as this. It's, as I said, it's changed you as a person. And I'll point out to you that it's now opening doors for you. It's opening doors for you that you see, and it's probably opening doors for you that you don't even know exist as of yet. And that's something that you should really feel proud of. So I'd like to congratulate all of the undergraduate researchers here today first. It's now my pleasure to welcome our guest speaker, Corey Fleischer. And when Janet asked me to do this, I said, of course, sure, I'll help out. And then I recoiled back and tried to figure out what I was going to say. And what I actually did is I went back and dug through my files, and I found the original letter of recommendation I wrote for Corey for his Undergraduate Research Award. And it starts off like every other. It was written 27th of February 2004, so I actually got it submitted on time. And it goes on, and it starts off like most letters of recommendation. I met Mr. Fleischer in my class. I've seen him in the mini Baja team, et cetera, et cetera, et cetera. And I ended that paragraph with, I'm very happy to accept Corey as a new addition to my research team. The funny part about that is Corey was my research team at that time. He didn't know that. But he was my research team. He was my research engine. And we did it together. The letter goes on to say how Corey's cunning, he has drive, he has motivation, natural gifts, all these things that you'd want in a researcher. But I then end the letter again with a statement that I think resonates very strongly is, Corey is driven beyond the norm and leaves a fingerprint of pride on all of his work. And I think that that is something that resonated with me, and it resonates with everybody who gets to interact with Corey. This fingerprint of pride he leaves on his work. And I can say right now, Corey, your department, your institution, your university is very, very proud of all of your accomplishments. And thank you for coming back and spending the day with us. Corey Fleischer. Thank you. And he's nervous.
Yes.
Corey and I talk about this a lot, that when you're nervous, it means you care. You're proud of your work. So he's very nervous.
Thank you. That doesn't help.
We had an interaction yesterday. He goes, I'm really nervous about this. I said, yeah, so am I.
So yeah, first off, I want to say how awesome it is to be back at the URCAD event. It's crazy. I didn't know it was exactly 10 years ago since I was part of the undergraduate research community. Oh, that's crazy. Let's get started. Oh, yeah. There we go. So I got into engineering, just like most mechanical engineers. I like to build stuff. I like to take things apart. My parents are here. They'll back that up because I rarely put things back together. But I always, growing up, I kind of wanted to be an inventor. I didn't know what a mechanical engineer was, never heard that title before. And it wasn't until I got into high school when I was part of this tech magnet program where I was part of a team where we built an it was an electrothon vehicle. It was a single passenger electric vehicle, kind of like an electric go-kart. And we learned how to weld and calculate gear ratios and things like that. And I got sucked into it. I remember I was showing up after school hours to work on the project. I was showing up on days when school was closed. I was meeting with the teachers to work on it. And I was just really passionate about it. And at that time, I talked to one of the teachers. And actually, he pulled me aside to ask me what I wanted to be, what I wanted to study in college. And I told him I still hadn't decided. And he basically said, you want to study mechanical engineering. And it was obvious to him what I wanted to study. When he explained to me about automotive racing and roller coasters and what mechanical engineers do, I knew that was exactly what I wanted to be. So naturally, I built an electric go-kart. Once I got to UMBC, I jumped right into mini Baja. And this was an unbelievable opportunity here. And Steve here is kind of the guy who took over the torch after I left. But the mini Baja program was amazing to get the fabrication skill. And you learn the hard way in engineering, and especially with hands-on fabrication. We break a lot of things, and those are, every time you break something, you're just a step closer to being successful. So I owe a lot of my kind of the garage engineering skills came from mini Baja, and there's no really other way to learn those. So I got into undergraduate research through mini Baja. I met Dr. Zupan. I had a class with him, material science, and it was actually the first time I kind of saw the material science side of engineering. When you think of mechanical engineering, you don't really think of material science, but it's such a dominating factor. Fun fact, right? The Titanic. We all know the Titanic sunk because it ran into an iceberg. But what a lot of people don't know is that the steel they used, they use the high carbon content steel in the hull structure, which has this brittle transition temperature. Basically, when the steel gets cold, it fractures like glass. It doesn't draw out or bend like steel does at room temperature. They didn't know that at the time. Had they gone with stainless steel or low carbon steel, it wouldn't have been as catastrophic. So learning things like that in the material science class really kind of got me to focus on material science. And on mini Baja, I started looking at composite structures. I really wanted to get like a carbon fiber component on the vehicle. So I was talking to Dr. Zupan a lot about that. And at the time, I had an internship at an HVAC company doing two-dimensional drawings, and I was miserable. So I came to Zupan, and I told him, I was like, I have an internship and I hate it. Can I work for you doing undergraduate research and help in your lab? And he took me on, and he had me help put his lab together. We designed test fixtures and things like that, and set up his lab, and it was a lot of fun. And that's how. And then I went from helping him set up his lab to actually starting to do tests and started to test these advanced composite structures, sandwich panels. And I put the Formula One race car over there on the right because it was real close to me, these sandwich panels, because McLaren had kind of established the honeycomb composite sandwich panels in the chassis for their Formula One cars. So I knew I was working with the leading edge materials, and it was real great to actually be part of the science aspect. And I never thought I would get into the research side of engineering. When I enrolled at UMBC, I did not think I would. The thought of getting a master's degree in material science was not even close to being in my head. So for my undergraduate research, I did a lot of panel testing for what was pin-reinforced sandwich panels. I think it was produced by this company, Aztec. It's a foam core, and they go through in the z-axis and insert all these pins and lay up face sheets over top. And it was a really great concept. When you look at the ingredients for these sandwich panels, they really hit the nail on the head by coming up with something that was, brought a lot to the table. So it was great seeing those materials and actually getting to perform mechanical tests on them. I got to do compression tests and three-point bending tests. And these are things you can't you can't learn in a classroom. You can read books and you can see the stress-strain curve, but when you're running a test and you're actually seeing that stress-strain curve grow, and you're doing repeatability tests, and you're sitting there hoping that your next test fails at the exact same time the test from yesterday failed, it's a great feeling. So at the same time, when I was doing this research with Dr. Zupan, Lockheed was investing heavily in survivability. There was a bombing of the USS Cole where a small powerboat motored up to the side of the Cole and set off some explosives and put it was like a 10-meter hole in the side of the Cole, and several sailors lost their lives. And it really showed that, here's a ship with the most powerful and advanced missiles on it, and it couldn't even stop a little motorboat from coming up and blowing a hole in the side. So it shows that we're always going to be vulnerable, and the U.S. Navy is always going to need advancements in survivability. So Lockheed was looking into advanced ballistic and blast protection, And just to show you how important blast protection is on the material side, the JLTV here on the right, 1/3 of the weight of that vehicle is just the ballistic armor. So working with Zupan and his material, and his the sandwich panels, I got to network and meet some of the people over at Lockheed Martin, Middle River, through Dr. Zupan. And here's a picture. Zupan just sent me this. I guess this was about 10 years ago, and this was me at Lockheed Martin in one of their assembly facilities. And it's crazy because, so I ended up, after graduating, I immediately just started working full-time for Lockheed Martin. So now I work with these people, and it's crazy to see that photo there. So after I graduated with my master's degree at UMBC, I started working at Lockheed Martin, and right away I got to work on some cool things. I got to design a next-generation missile launchers. I was a primary designer on the Seaway system on the right, which was a crew transfer. It's this foldable, collapsible ramp system to get people from ships 4 stories up onto oil platforms. It's a big problem getting crew members on and off oil platforms. A lot of times they use like these baskets or helicopters, and they have occasional crashes, and it's really a high risk. So that's what I'm doing now at Lockheed Martin. I still get to work on a lot of research and development projects. I'm still there. I've been at Lockheed about 7 years now. But I love my job there. And it was when I was working at Lockheed is when I got picked to be a contestant on Discovery Channel's The Big Brain Theory, which is still unbelievable to think. It's still crazy that I got picked. I still can't believe I did it. Because I was actually just talking to my mom about this beforehand. I remember being on the airplane. Okay, so let me explain the show in case you missed it. It's one of those competition reality shows like Top Chef or Top Shot where, there's 10 contestants. Every episode they give us an engineering challenge, and we had to split up into teams and compete for this challenge. And then the losing team would have somebody eliminated, and you go down until there was only one contestant left. And this actually reality show is really unique because every challenge needed 2 teams of 5 people. So every time somebody's eliminated, they'd still have to stick around and help out for future builds. So you definitely it was important to not get anyone on your bad side because you may need them down the road to help you out. But it was crazy. This was the first time this show had ever been aired. This was the first season. So I didn't know what to expect. And I remember being on the airplane, going out there, thinking that they could literally just put us all on an island and say, engineer your way off. I had no idea. I knew I was going to be on camera, and I knew I was going to be gone for 2 months, and that was pretty much all they told us. And I just hoped it actually had, because I always thought in the back of my head, like, it'd be funny if it wasn't an engineering thing. Like, what if this was like Big Brother or something that I accidentally applied for? So I had no idea. So luckily it was what I expected it to be. And Dr. Hrabowski said earlier, he said it's cool to be smart. I don't know if he says that a lot, but I think this, I hope he does. But I think this shows, that kind of reinforces that statement because this was by far the most expensive show Discovery Channel's ever done per episode. And it goes to show that there's that much interest, in the United States, in young, viewers, that they can actually invest in something like this. I guess I wouldn't have expected, when I was younger, I don't think I could have looked forward to something. I would have loved to see something like this on TV, but there wasn't because there probably wasn't the audience. But there is now, and I think that's great. All right, so a lot of people ask why I got picked and how I got picked. And a friend of mine, basically the Discovery Channel put out a call for applicants on the internet. And they originally called the show Top Engineer, which I really wish they'd kept that title because yeah, exactly. I guess that's why they didn't do it, but the Big Brain Theory I don't think I would have applied to that. So Top Engineer was what the call for applicants was, and it was basically asking for any engineers or inventors with hands-on fabrication skills and outgoing personalities that wanted to participate in this reality show. So a buddy of mine saw it, and he forwarded it to me and was like, hey, you got to apply to this. So we wrote up this really goofy Actually, I wrote up an application, and it was really dry. It was just like, I like to build stuff. I'm Corey Fleischer. I have a master's degree. And he was like, no. And he turned it and made it absurd. He said, I remember the opening line was like, fueled by adrenaline and caffeine, Corey Fleischer. And I sent it on. I went with his advice, and it worked. So I actually got a response from him, and they wanted pictures of projects that I had built. So I sent him these. And 3 of these I built here on campus. Mini Baja, I actually wasn't on that team, but that was the best picture I could find. I built the mini trike in the Mini Baja shop along with some other guys in some downtime between working on the car. And Dr. Zupan, I'm sure you remember the motorized bar stool. Yeah. It was electric. So, I guess I could talk. It's like I could talk about these things now, right? I'm so far removed.
Motorized bar stool was in the lab for a long time.
Yeah. I probably couldn't admit to some of these things at the time. And then in the top right, this was my latest build. This was a Bluetooth-controlled go-kart. It's controlled wirelessly by a Wii remote. Basically, you just turn the Wii remote, and it knows which way is up and turns the wheels. So it's like a real-life Mario Kart. And Discovery Channel loved that. And I feel like it's so a crazy coincidence that I actually built that just in time. Like I just finished that just in time to show them videos of it. And then in the lower right, I built a CNC plasma cutter in my garage. So that's yeah. I guess that's what engineers do, right? When we graduate and we have more free time, we build go-karts. Yeah, can you hit next over there? All right, so the challenges. The challenge on this show were unbelievable. And I remember, like I said, I was so nervous because I didn't know what to expect. I have a weakness in writing software. And that was my biggest concern going out there. Like, what if they just put us with a whole bunch of robotic kits and write software was the big thing. So I was kind of worried about that. But the very first challenge is shown in the upper right there. So we show up on site, and we hadn't even talked to each other at this point. None of the cast members. We couldn't say a word. We had this handler guy who walked around with us, making sure we didn't talk. And they just took us out to this desert-looking field, and there was 2 full-size pickup trucks spaced far apart, aimed at each other. And we still had no idea what they were going to do. And then they said, okay, here's your challenge. They pulled on this cable, and these 2 trucks slammed into each other about 40 miles per hour. And then both had these explosions go off. And they're like, that's your challenge. They had these boxes of explosives that were set to detonate at 20 Gs, and we had to keep those explosives from detonating. So we had to come up with some energy-absorbing mechanism. And right away, I knew energy absorb. It was ridiculous that was the first challenge because Dr. Zupan had me calculate energy absorption probably hundreds of times. Every test that I ran, I had to calculate the energy absorption. I had to do all these exercises to figure out what that meant. So many times, I had sections in my thesis talking about the importance of energy absorption and crust strength and all that. So I was very familiar with it. And there was times when I was explaining to the other team about strain softening materials and mechanisms. And unfortunately, both teams lost that challenge. And another fun fact, we lost this challenge, material selection. So my team, we built this. I'm getting way off on tangents. I'm going to go way over my time. We built these long rail system, and we had built a carriage for the case of explosives, so that when the vehicles hit, our carriage with a brake system would run along the rails, slowing, bringing it to a descent, or bringing it to a still. And what happened was, and we experimentally, honed in the brake force, so we knew that we had the perfect brake force to have the lowest possible Gs. And what happened was our carriage, and you can watch the videos, our carriage started to slide, and once it slid about 6-7 feet down, and this was a 14-foot length track, it just stopped, and then the explosives went off. Problem was, we used aluminum brake pads on a steel rail, and the material galled. No idea. Had we done another shot, we would have nailed it. And you think of galling, helicoils and aluminum. I'm familiar with it, but I had never knew that it could take place, something like that. And I was thinking, we had to make so many decisions in 3 days. We missed one detail. And luckily, our team was picked to win, and we didn't have anybody eliminated. But good lesson there. The left, this was my favorite challenge. We had to build a robot that could perform 3 decathlon events. The sprint, javelin launch, and standing long jump. And yeah, I was picked as a team captain for this, and it was crazy that there's only been a handful of jumping robots ever built. Most of them have taken years of development, millions of dollars, and we had 4 days and $10,000, and our robot actually jumped 16 feet. And you should see the production crew went nuts because we had failed every challenge. This is challenge 4. And both teams had failed every challenge going up to this. We thought they were just going to pull the plug on the show, that they would finally catch on that they got the wrong 10 people for the show and start all over again. So when our robot jumped, man, everybody went nuts. The camera people were high-fiving us. It was a great feeling. And then in the lower picture there, this was a renewable energy challenge. They built this 3-story waterfall. They had 40 horsepower of flowing water coming down, over this layer, created waterfall. And we had to harness the energy from that falling water and use it to power an elevator to lift one of our team members up 3 stories in the air. And we built this giant water wheel with this electrically controlled sluice gate system, so we could, and we had encoder wheels to let us know what level it was. So we could just press a button. We would press like floor 2, and the elevator would go up to the 2nd floor. Another thing, and this is why I'm getting so far off topic. This is why I love the first robotics competition, because there's a human nature. Competition is in our DNA, and it brings out the best, because I would have never thought that me and 4 other people could build an electrically controlled elevator powered by a waterfall in 4 days with $10,000, and we did it, and it performed flawlessly, and I guess there is another aspect of being in front of a camera to help motivate you too. You don't want to look like a slacker. You don't want to be caught with your feet up on the desk while everyone else is working. So I debated about putting this in. This is going to sound cliche, but it's true. There were several times where my material science background really came through in the competition. I think one of the main reasons I won was because I was probably the most diverse engineer out of the 10 contestants. There's only one other guy with a good material science background. He was a rocket scientist, and he was the first one eliminated. He had no team dynamics. His social skills were bad. I mean, he had the highest IQ. He had a genius level IQ, and he was the first one eliminated. But next to him, nobody really had that good of a background. And here in the lower right, challenge 3, we had to design some kind of a bunker to protect us from 3 deadly elements, right? They blasted us with high wind velocity, 1900 degrees Fahrenheit flame torch, and then this ridiculous water cannon that it was like firing a stream of bowling balls at us. So, actually, it was one of the Bellagio fountains. It was one of those water fountains turned sideways at us. So, and I did all the panel design for that. I did so many calculations, and they didn't even that's one thing disappointing, because it just looks like we threw these things together, but there's so much science. Not once is there a shot of us running through all the calculations. So it's just a shame, but Zupan, you would have been proud to see me doing all I actually designed those as honeycomb panels. I did all the calculations for honeycomb, but we couldn't get honeycomb in time. That would have saved probably 20% weight. So we went with polycarbonate instead. So the championship. So I was the winning contestant on the Big Brain Theory, and which is, man, unbelievable still. 8,000 people applied to be on the show, and 10 of us were picked, and then I ended up winning. So I remember on the very first challenge, when they, before we actually got into the shop to start building, they kept saying that we were 10 of the smartest people in America, and I remember just like laughing, thinking that I fooled them, and I was just gonna be the first one eliminated because we hadn't talked. And then once we got back to the house and kind of started talking about each other's backgrounds and things, then I started to feel more comfortable. And then once I got into the shop and I saw the MIG and TIG welder, it was the exact same TIG welder that we had in Mini Baja. So I mean, once I got in the shop, I was comfortable. It was good. But so the championship was me and this contestant Amy went head to head, and we had to build a deployable bridge. So the bridge had to collapse and fit in the back of a pickup truck, and then we had to pull up to the side of this gorge and deploy the bridge from one side, and then actually drive the truck across it. And I was so nervous going, and there's so much time before these, like when they take us to the competition days, the tail of the challenge, it's like it takes 6 hours before they actually show us the challenge. Like we're just there all day. And it was the first time where I stopped having fun was when I was in the championship. Because now, like, I just assumed I was going to get eliminated. And then when I finally got to the end, and I was me and one other person, competing for $50,000, that's when it wasn't fun anymore. Then I was really like, wow, this is real. So, but then once they showed the challenge right away, I knew it was almost like my friends had designed this competition, this challenge for me, because I had a lot of experience, fabricating aluminum and metal structures. So it was great, and I ended up winning. And you can't see in the right picture on the right, the guy in the lower side with the white shirt, that's Buzz Aldrin, who was the guest judge. And it was great hearing him talk, say all these great things about the bridge that my team built. So it was really cool getting to meet him. So another common question I get is, how did I prepare for the show? I knew that this was going to be the best chance I'd ever have of winning $50,000. So I trained like crazy. I learned all the solid modeling software tools I could get my hands on. I did some practice TIG welding just to brush up on my welding. I got into electronics. I dug out my Arduino and started doing a whole bunch of software and electronics projects. That was my weakness. And I taught myself Mastercam just in case we had the CNC capabilities, which we did. And it's funny talking to other people on the show. So that was a big thing, like, oh, so how did you prepare? And everyone else prepared by watching all the other reality shows they could find. And I'm so glad that's the approach that they took, because I didn't watch any. And it wasn't like the typical one. There wasn't alliances where you could, bottom line is, you win the challenge, no one on your team gets eliminated. So, and I had a talk with a friend of mine before I left, like, should I strategize? And he was like, no. He was like, just win. So I stuck to his advice and won. No. All right, so final thoughts. I was told that anytime you give a presentation, you should leave the audience with something to walk away with. So I want you to walk away with, for the people part of the research, the undergraduate research event, take ownership of your research, because you never know where it's going to lead you. You never know when you're going to need it in the future or what doors it's going to open for you. And also stay passionate about science, because that's why that's why we're in school, to learn. So keep, maintain life learning, and keep your subscriptions, the Popular Mechanics and all that stuff, because you want to stay on top of things. So, thank you.